In the last video, we learned how to use free LLM models for our OpenClaw bot. And if you already tested it, you probably noticed something important. A single free OpenRouter account can hit the rate limit very quickly. Just a few chat messages, and boom, limit reached. So in this video, we're going to solve that problem properly, and not just manually. We're going to build an automatic API key rotation system, which means when one key hits a rate limit, the system will automatically switch to another valid key. No interruption, no manual work. And most importantly, still completely free. So instead of being limited by one account, you can scale using multiple free API keys. Alright, enough talking, let's get started. To manage multiple API keys automatically, we're going to use something called CLIProxy API. Now let me explain this simply. CLIProxy is basically a smart gateway. It sits between your OpenClaw bot and your LLM providers. Instead of OpenClaw talking directly to OpenAI, Gemini, or OpenRouter, it will talk to CLIProxy first. And CLIProxy will decide which API key to use. Here's the flow. We use OpenClaw bot, or even N8N workflow, to send a request to CLIProxy API. Inside the header of the request, it includes one authentication key. That key is used to access CLIProxy. Then CLIProxy receives the request. It checks the key and forwards the request to a provider, like OpenRouter or 02 Launch, OpenAI, Gemini. But here's the powerful part. Each provider can contain multiple API keys. So if one key reaches its rate limit, CLIProxy automatically switches to the next one. So instead of one free key, you can combine 5, 10, or even more. That means 10 times more usage. And for agentic AI systems like OpenClaw, that's a game changer. Now that you understand the architecture, let's install it. First, go to your VPS server. Or if you're running everything locally, simply use your local machine. Once you're there, open your terminal, because this is where we'll begin the installation process. Now go ahead and run the install command for CLIProxy. When the installer starts, you'll see a few options appear on the screen. We're going to choose option number 1. Keep in mind that this is an open source project originally from China. So if parts of the interface aren't in English, don't worry, you can quickly use Google Translate to understand the configuration steps. After selecting option 1, the installer will ask which port you want to use. We'll stick with the default port, 8317, since that's perfectly fine for our setup. Next, it will prompt you to create a management key. This step is extremely important because this key acts as the password to access your CLIProxy dashboard later. So make sure you enter a secure password and store it somewhere safe. Once you confirm that, CLIProxy will automatically download the required Docker image and start running. And just like that, the installation is complete. Now that installation is done, let's make sure everything is actually running properly. Press Ctrl+C to exit the current console view. Then type Docker PS in your terminal. This command lists all currently running Docker containers. If you see CLIProxy in that list, that's exactly what we want. That confirms it's running successfully in the background. With that confirmed, let's move to the dashboard. Open your browser and enter your VPS IP address, followed by :8317. If you're hosting everything locally, you can simply use localhost 8317 instead. Once the page loads, log in using the management password you created earlier. And just like that, you're inside your CLIProxy dashboard. Now we're ready to configure the API keys. Head over to the config panel, or click on management keys depending on the layout you see. At the top, you'll notice a field labeled API keys. This key is different from the provider keys. This one is used to authenticate external services, like OpenClaw, when they connect to CLIProxy. So generate your own secure API key here, and save it carefully because we'll use this later inside OpenClaw. Next, scroll down until you find the OpenAI compatibility section. This section is crucial because it allows CLIProxy to work with providers that support the OpenAI-compatible API format, including streaming responses. We'll uncomment this section and remove any unnecessary placeholder configuration. You'll notice that a template for OpenRouter is already included, which makes things easier for us. Now focus on the API key entries inside that provider configuration. This is where the real power comes in. Instead of adding just one API key, you can paste multiple keys here. For example, if you create 10 free OpenRouter accounts and generate one API key from each account, you can paste all 10 keys into this list. CLIProxy will automatically rotate between them. That means instead of being limited by a single free account, you effectively multiply your available requests. So go ahead and create multiple OpenRouter accounts, generate their API keys, and paste them into this configuration. Once the keys are added, we'll configure the model. Go to OpenRouter's model list and copy the exact name of the model you want to use. As we discussed earlier, we'll use NVIDIA's Nemotron model since it's optimized for agentic AI systems. Paste the exact model name into the configuration and then assign it a simple alias so it's easier to reference later. You can also configure additional providers such as OpenAI, Gemini, and remember, each provider can contain multiple API keys for rotation. After everything is configured properly, click Save. Now it's time to test the setup. Open your terminal again, or use a tool like Postman if you prefer. We're going to send a request to the CLIProxy endpoint, which follows the standard OpenAI-compatible API format. In the request body, specify the model name or alias you configured earlier, along with your user prompt. In the header, add an authorization field using bearer, followed by the API key you generated for CLIProxy authentication. This ensures that your request is properly verified. Now send the request. If everything is configured correctly, you should receive a successful response. You'll see the reasoning output along with the final response text inside the content field. That confirms that CLIProxy successfully forwarded your request and used one of your OpenRouter Nemotron API keys. Let's try a different prompt, and you'll see that you won't hit the LLM API rate limit. To be extra sure, you can also test it directly inside your VPS using a curl command. If that works as well, then your setup is fully operational. The next step is to connect everything back to OpenClaw. So now we're going to update the ClawBot configuration file and set CLIProxy as the main LLM API endpoint for our OpenClaw bot. There are two ways you can do this. You can either directly edit the openclaw.json file on your VPS, or you can use the OpenClaw web dashboard to modify the configuration. Just one important note, if your web dashboard requires a token to sync with OpenClaw, make sure that the token inside your JSON configuration file matches the one used by the dashboard. Otherwise, they won't sync properly. Once your OpenClaw dashboard is accessible, go to the Config tab and switch to the raw view. Here you'll see the configuration file displayed exactly the same as the openclaw.json file stored on your VPS. That means you can edit it here directly, or edit the JSON file via SSH. Both methods will work. Now let's update the configuration. First, we'll add the CLIProxy API key under the env field. This is where we store environment variables like API keys. Make sure you copy and paste the exact CLIProxy API key that you created earlier inside the CLIProxy dashboard. This is the key OpenClaw will use to authenticate when sending requests to CLIProxy. Next, we will update the authentication profiles to use CLIProxy instead of directly using OpenRouter. Next, we need to define a new model object. You can grab the example syntax from the video description if needed. This model object allows us to merge a custom LLM provider into OpenClaw. In this case, we're telling OpenClaw to use CLIProxy as a provider and specifying its configuration details. Now you'll see something like 127.0.0.1 in the base URL field. Let me explain this clearly. This IP address is essentially the same as localhost. It means this machine itself. Because we installed CLIProxy inside the same VPS as OpenClaw, both services are running on the same host. That means OpenClaw doesn't need to call an external IP. It can directly call the local endpoint. You could technically use your VPS public IP address, but using this local IP is cleaner, faster, and avoids unnecessary external routing. Since both OpenClaw and CLIProxy share the same server environment, this setup works perfectly. Then we configure the model to use the API key from the env field we just defined, and we specify the LLM model name that CLIProxy supports. In our case, the Nemotron model alias we configured earlier. After defining the provider, we move down to the agents field. This is where we set the default primary model for the bot. Here we'll assign the CLIProxy Nemotron model as the primary LLM. The reason is simple. We want to avoid spending money on direct paid APIs when possible. Now, if you do have a valid OpenAI API key, you can configure OpenAI models as fallback models. That way, if CLIProxy happens to hit rate limits across all OpenRouter keys, OpenClaw can automatically fall back to OpenAI. Make sure you specify both the model name and its alias properly in the configuration. You'll also notice fields for maximum concurrent requests for agents and subagents. For now, we don't need to worry about tuning those. The default values are fine. Once everything is configured, click Save. If the dashboard disconnects after saving, don't panic. Just reconnect to your VPS using SSH and everything will continue running normally. Now that the configuration is updated, let's verify it. Go to the Agents tab inside the dashboard. You should see that the primary LLM model is now set to CLIProxy Nemotron, and the fallback models are your OpenAI models. That confirms that OpenClaw is now successfully configured to route and handle API key rotation through CLIProxy. Alright, now let's test it live. Go to the chat box. Feel free to ask any question to your bot. You can also use the models command to list all available model providers currently configured. And if you want to see models under a specific provider, you can list them individually. Now let's try something practical, maybe a coding question, just to see how the Nemotron LLM handles it. And awesome! It responds smoothly, no rate limit errors, no interruptions, and behind the scenes CLIProxy is automatically rotating between your API keys. And this is the real power of this setup. Now your OpenClaw bot is no longer limited by a single free account. Instead, it intelligently routes requests through a rotation layer that maximizes free API usage, increases stability, and gives you a scalable foundation for agentic AI workflows. From here, you can expand this system even further, adding more providers, more keys, or even building monitoring layers on top. But the core idea remains simple: abstraction and rotation give you control. And that's it. You now have a fully working OpenClaw setup with automatic API key rotation. Now, if you want even better performance, and you also don't want the headache of creating a bunch of OpenRouter accounts because you don't have that many Gmail accounts, there's a cleaner option. Instead of stacking tons of free keys, you can simply use higher performance paid LLMs that can compete with expensive APIs like OpenAI or Claude, but at a much more practical cost. For example, you can use models like Kimi 2.5 or Qwen 3.5 Plus through our system. They're faster, smarter, and much more stable for real workflows, especially when you're building serious agentic automation with OpenClaw. These models are available for our paid members, and in the next video, I'll show you exactly how to plug them into your OpenClaw setup step by step. Alright, see you in the next one.